swear I read this. All right. All right. Yeah, what's going on, everybody? How's everybody doing? On chapter 6. All right. I think I was on chapter 6, but I was reading that one off stream. So let's do chapter 7 and keep it pushing. I'll come back with chapter 6. All right, cool. Let's get this going. What's up, everybody? How you doing? Anybody in here? Got 3 people in here. What's up? All right, you guys. Today we're gonna be just doing some reading, having some fun, chilling out. Learning some Python. Learn more about Python, and just keep practicing, you guys. You know, this is what sets people apart, in my opinion, and from what I've researched about, the people that do the reading and do the work to learn more, when they don't want to, and put in the practice day in and day out. So applaud to you guys if you're here with me, grinding. This is what it takes. I'll see you on the other side, boys. All right. I think I'm gonna keep the tunes on just in the background to keep me from drowning out my thoughts. All right. All right, we're going to do chapter 7, functions as first-class objects. I'm just going to try to keep this more chill. I think my issue is with learning is that why I kind of burn out a little bit is I was kind of taking it too serious, and I need to keep it's chill. It's just like, it's fun. It's like I don't have to absorb it all on the first go. Just let it come to me and let's have fun, Okay, let's keep it rolling. I've never considered Python to be heavily influenced by functional languages, no matter what people say or think. I was much more familiar with interpretive languages such as C and Algol 68, and thought I had made functions first-class objects. I didn't view Python as a functional programming language. Functions in Python are first-class objects. Programming language researchers define a first-class object as a program entity that can be, okay, so it's a first-class object um, a program entity that can be blank. 1, created at runtime. 2, assigned to a variable or element in a data structure. 3, passed as an argument to a function. 4, returned as the result of a function. Okay. Integers, strings, and dictionaries are other examples of first-class objects in Python. Nothing fancy here. Having functions as first-class objects is an essential feature of functional language such as Clojure, Elixir, and Haskell. Is it Clojure? Is that how you pronounce it? However, first-class functions are so useful that they've been adopted by popular languages like JavaScript, Go, and Java since JDK 8, none of which claim to be functional languages. This chapter and most of Part 3 explore the practical applications of treating functions as objects. So we're going to say functions are functions in Python are first-class objects. I gotta start the Twitch. Is there anybody in here? Nobody on a chat? Where's everybody at? Where's everybody? This thing on? Is this thing on? There's 5 people here. Okay. The term first-class functions is widely used as a shorthand for functions as first-class objects. Okay. It's not ideal because it implies an elite among functions. In Python, all functions are first class. Okay. What's new in this chapter? Whoa. Pardon me. The section, The 9 Flavors of Callable Objects on page 237 was titled The 7 Flavors of Callable... Okay, this is just what's new in the chapter. Skip this part. Now let's see why Python functions are full-fledged objects. Treating a function like an object. The console session in example 7-1 shows that Python functions are objects. Here we create a function, call it read its doc attribute, and check that the function object itself is an instance of the function class. So here's example 7.1 where we create a test function and read its dunder doc and check its type. So def factorial of n returns n factorial. If n, return 1. If n is less than 2, else n factorial by times factorial of n minus 1. So a recursive call on itself. So then we return factorial of 42, and then we call factorial dunder doc in number 2 here, and it says quote returns n. Okay, so this just this doc just returns the doc string. Okay, that's interesting. I didn't know that. Huh. And then we call type factorial, which is a function. This is a console session, so we're creating a function at runtime in number 1. Doc is one of several attributes of function objects. Factorial is an instance of the function class. The doc attribute is used to generate the help text of an object. In Python, the Python console, the command help factorial will display a screen like 7-1. Yeah, Lance, this book is free. Yo, I have this book. All my books I'm reading and everything I provide for you guys completely for free, and where I find them in my Discord, as well as my notes that you guys see on the right hand of my screen. They're on my GitHub as well. Everything's in my Discord, just kind of like a roadmap. Just a mosh podge of all this stuff. It's a cool place to be. So join the Discord link in the description. And read along with me here. In the Python console, the command help factorial will display a screen like this. Help on a function factorial in name module main. Help screen for factorial. Example 7-2 shows the first class nature of a function object. We can assign it a variable fact and call it through that name. We can also pass factorial as an argument to the map function. Calling map function iterable returns an iterable where each item is the result of calling the first argument function to a successive element of the second argument iterable, right? So you just map the first function to every item in the iterable, right? With the map function. Range 10 in this example. So here we have fact is equal to factorial. We call fact, and then we can call fact 5, and that will give us 120. Map factorial range 11 provides a map object. We convert that to a list, we get this back. Okay, cool. So we can assign it a variable fact and call it through that name. Interesting. I didn't know you could do this why would you want to like do this? Why would you ever like rename a variable like this? Well, my boy Lance, this is more, I guess this is more of like getting into more like advanced, kind of more Python, I guess intermediate to advanced. So like kind of more like, you know, tricks and things like that, tricks of the trade. It's like I have a good understanding of Python, but I don't know a lot of the more advanced like modules or features or little quirks or whatnot. So this book is called Fluent Python. It gets into all that kind of those nuances and more of the deeper stuff. Pause. Having first-class functions enables programming in a functional style. One of the hallmarks of functional programming is the use of higher-order functions, our next topic. So, let's go here. I am reading Fluent Python. Let me use the speech parameter. I'm reading Fluent Python chapter 7, and I am on example 7-2, where we rename, you know, to show that the factorial function is a first-class function. We assign it a variable fact. We kind of give it an alias, just as you could give like a reference object in Python, like a list or a dictionary, an alias to, you know, do work on, and it both would reference back to the same place in memory, like a pointer. Is this just showing that functions are also kind of following that same attribute that they apply as objects themselves? Do we have is functions objects? Oh, I guess nature of a function object, yeah. You got it exactly. What example 7.2 is trying to emphasize is that Python functions are first-class objects. That means they behave in the same fundamental way as other objects. You can bind them to a variable, you can store them in data structures, put them in a list, dictionary, etc., and you can pass them as arguments to other functions. You can return them from functions. You can even return them from functions. Now, fact and factorial are both names referring to the same function object in memory, exactly like giving a list another alias. Both nums and alias point to the same underlying list, same with factorial and fact. They're two names for the same function object. So yes, functions in Python are objects in their own right of type function they have created at the runtime and have attributes, name, and doc, and can be assigned around and manipulated like any other object. So I'm curious to like what's like the use case for this? Like I get maybe we're going to get into some functional programming as the book is alluding to, but like why would we ever want to assign aliases functions or store functions in a data structure? I've never done that before. It seems kind of, yeah, like I mean, you could probably store in a data on a list the call on a function and then like as a generator and then unravel the call of all of those. But that's the same thing as just looping through the list and calling the function, So, I mean, that's or just mapping the function like they're doing to an object or an iterable. So it's just kind of showing you multiple ways to do the same thing, maybe quicker. That's a really sharp question. You're noticing that the first glance, this functions are object things feels like just an academic curiosity because you could always just call the function directly, but there are some very real use cases where treating functions as values or first-class objects gives you flexibility and cleaner code. Here are a few practical patterns where it matters. Higher order functions pass around. You already mentioned map, but the bigger idea is that you can write general logic and plug in behavior. So def apply twice, we have a function. We take in function and have an x value, and we return function of function x. Apply twice, stir upper hello. Apply twice lambda. N plus 2 on 5 will give us up to 9. Here's the thing that changes is the functions, not the framework around it. Storing functions in data structures, think of a simple command dispatcher. Instead of a long chain of if-elifs, you can just store functions in a dict key command. Oh. This pattern shows up in CLIs, routers, GUIs, game engines, etc. Oh, wow. We are being enlightened. Interesting, right? So you can just quickly get O1 access to the function call. Oh, wow. And like make your conditional be the key. GUI framework async code event loops rely heavily on being able to pass function references called later. So we have import time, alarm, print, wake up. In schedule, it takes in function and delay. We sleep this delay and then we call a function. So we schedule an alarm with a delay of 2 seconds. You couldn't do this if you couldn't treat functions as a value. Dynamic behavior selection. You can make code extensible by choosing which function to apply at runtime. Import operator. Here's our operators. Add, subtract, multiply. Op equals multiply. Print ops. Op. Operators, operator. 3, 4. And I'll multiply those together. Avoids having to hard code conditionals. Super common parser. Oh. You can build a sequence of operations as data and then apply them. Double square returns 2 times x. Or double x returns 2x. And def square x returns x times x. And pipeline. Double square absolute value and you have a value. And then you apply x to every value in the pipeline. Oh, wow. I've never even thought about programming this way. Wow. Like having your function be your object that you're iterating over and applying to a value, but you're iterating over a list of functions, a sequence of functions that you want to apply. So you can describe. Oh wow. You guys know about this? You guys know about this? We are being enlightened. Hold on one second, guys. Check my TV out. She's got a little bit of a... Bum here. She's got a little bit of a skin thing going on. I want to check her out. Okay. Higher order functions. A function that takes a function as an argument or returns a function as a result of is a higher order function. Higher order functions. Hold on one second. This says first class objects. Alright, yeah, higher order functions. The kitty, she's got a little bit of a... Can you see her butt over there? That's her butt right there. Shaved butt. She's been scratching at her butt recently. We've been, I had to shave it. I did make sure I cleaned it and stuff. It's been bothering her, and yeah, just cat things, you know. Embarrassing. She was like, she didn't like I kind of like lulled her to sleep by petting her, and she like woke up with the shaved butt. What the heck? Here, yeah. Okay. Higher order functions. A function that takes a function as an argument or returns a function as a result is a higher order function. Okay, so this is going to be kind of annoying because it has the word function in it. A function. I swear there's something on my leg. Maybe not. So yeah, I think I'm like, I have to talk to my apartment complex. Situation going on. Got a blanket anywhere though? No blanket. Watch out, Scabby, sorry. Watch out, Scabby. Watch out. Get down, get down. Watch out. There you go, go. Alright, put the blanket here. Alright, you can go. Alright. A function that takes a function as an argument or returns a function as the result. Right? One example is map. Example is the map function. shown in example 7.2. Another is the built-in function sorted. The optional key argument lets you provide a function to be applied to each item for sorting, right? Right, this has function and iterable. And this has key, which equals to none by default, right? Iterating key. The optional key argument, let's read right, okay. As we saw in list.sort, sorted versus the sorted built-in on page 56, for example, to sort a list of words by length, pass the length reference as the key. So we have fruits here: strawberry, fig, apple, cherry, raspberry, banana, sorted on the fruits, where the key equals to just length, right? Not call to length, but just the length function. So it's going to apply, or like probably map this function to each of the fruits and then sort them in that order. Any one argument function can be used as the key, for example, to create a rhyme dictionary. Hold on. Any one argument function can be used as the key. For example, to create a rhyme dictionary, it might be useful to sort each word spelled backwards. In example 7.4, note that the words in the lists are not changed at all. Only their reverse spelling is used as the sort criterion, so that the berries appear together. So example 7.4 here is sorting a list of words by their reversed spelling. So we have def reverse word, and we're going to return the word, where we are going to reverse it by accessing index, colon, the shorthand -1, which just for flips the string or the iterable, right? Now reverse testing gives us init set, and we call sorted fruits key equals reverse, right? We're going to sort it in reverse order. So you're going to you have this function reverse, which flips it, and now you sort on reverse. So what is it actually sorting? You have fig, apple, cherry. What is that actually doing? In the functional programming paradigm, oh, that's right. In the above paragraph, it says, in example 7.4, note that the words in the list are not changed at all. Only their reverse spelling is used as the sort criterion, so that the berries appear together. So you sort based on reverse. Okay, so the berries come together because they have similar sort, like flipped. Oh, and sorting by reverse. Oh, so this has A, E, G, Y, Y, Y. It's sorting in reverse It's sorting in alphabetical order on the flip strings. Okay. In the functional programming paradigm, some of the best known higher order functions are map, filter, reduce, and apply. The apply function was deprecated. Is it deprecated or depreciated? No, not depreciated. Is it depreciated? I don't know. In Python 2.3 and removed in Python 3 because it was no longer necessary. If you need to call a function with a dynamic set of arguments, you can write function *args *quargs instead of apply function to the args, your args on the keyword arguments. The map, filter, and reduce higher order functions are still around, but better alternatives are available for most of their use cases, as the next section shows. Function *args *quargs. Function *args and function *quargs is Python shorthand for calling a function with unpacked arguments. Args unpacks a sequence, like a list or tuple, into positional arguments. Keyword *quargs unpacks a dictionary into keyword arguments. So example, greet with name, city, age, and city. Hello, my name is, I'm blank years old and I live in blank. Alice, 30, New York is our args. And our quargs are name, age, and city. Greet args. Oh. Huh. Hello, my name is Alice Smithers. I live in New York. My name is Bob. Oh, okay. So you can just automatically you just unpack, right, a list or tuple or whatever, a set of the values. List or tuple, not set, I think. I guess be ordered. A list or tuple into the arguments, and then you can set the values explicitly, like with equals, as if, right, using a dictionary, and unpack those into the arguments. Gotcha. So I'm going to say, I'm going to do this. Higher order functions, map, filter, reduce. I'm going to say function *args *quargs. Right. So what does this do? This will unpacks the iterable or a dictionary and assigns the values, either the iterable self or the themselves or the dictionary values, Hey, thanks for the raid with the 1. I appreciate you, my boy. How's your study been going, Zero? You the man. You the man, you the man. Appreciate you coming in, my friend. We're just reading some Fluent Python right now and just having a chill night. Having a chill night. I've been programming at work. I'm basically like a... I don't know, dude. I'm basically like a chemical programmer. Like, that's kind of like my new thing at work now. I don't know. They've been letting me code for the past week as like my assignment, literally. Like, my job is to produce this tool and get it going, because they want, like, they need some results, I think, to, like, make themselves look good up to management. So that's what I've been doing, you guys, and I got a working tool. I figured it out. Me and my boy from the other team, we've been working together and we figured it out. We've got 2 working tools that do it and do what we need to do. It's pretty cool. Well, I say that as like kind of funnily, not funnily. I say that kind of jokingly because I'm a biochemist, but I'm a biochemist, but I just I've been pitching my company some automation tools, like via some Python scripts to, auto calculate some of our our chemical matrix formulations. I'm a formulation chemist and I build biological controls, and so I have to manually kind of calculate and manipulate a chemical matrix, and to predict a blend of many lots of serum together to produce a yield of certain values of constituents within the serum to be tested for, and within these various range, like map and suite, kind of like, for lack of better words. And so I was like, man, we could really just program this up with some help, and because we just are on some archaic tools and stuff like Excel, and I was just tired of doing it by hand. Like it would take me like almost all day to do it, and like I'd get like an okay one, and then I'd have to review it with my staff scientist to optimize it and get it better. And this one will just take all that. It'll just take all that away and it'll give you like a 95 to 98%, like, it'll get you right there, and then you can kind of tweak it how, like, a little bit. Just you move the numbers around just slightly to just kind of balance out the levels however you would like, but it'll get you like right up into that range you're looking for initially, and then you just tweak it however you like, if you want a little hot or a little cold in some areas. And I even added in some additional functionality to like shrink our ranges, to give us some better quality, like to hit on more fine ranges internally, so we like can, like, yeah, it's pretty cool. I don't know. Mike has that internal hire on lock. Just need someone to quit or oh, I don't know, dude. I don't know. I never asked him if his team was like hiring or whatnot. I didn't really. I mean, it crossed my mind once or twice, but I don't know. I was like, I gotta kind of prove myself here, and it's kind of cool. Hopefully, we did like some peer programming, and I like in we were able to build some stuff together and get it going. So yeah, it's kind of cool. I implemented today. What did I do today? Yeah, today. So we really want to prioritize off of like we really wanted to prioritize like like constituents of solution that were going to expire first, right? You want to like you want to do that, and so I what I did was I just applied like a weight to each serum, and if it was used, um, no, I applied a weight to each serum corresponding to its expiration, um, and then just incorporated that weight into the linear program, and as like its minimization factor across the entire array, and it'll give you like you can do some manual tweaking, right, to fine tune even more, but it'll give you like the summed minimum across the entire suite of serums. So now you can kind of cherry pick it and throw some of the later ones, the ones that are further out, right? Like not give it to like kind of cherry pick it even more. But you know, yeah. So maybe I could write in like maybe I could write into not even try at first for serums that like are extended like let's say 2 years, and then if you can't find feasible solutions, then start extending rather than having to just manually limit what you give it. How did I decide on Python? Just to build kind of tools like that. It kind of has been pretty useful for stuff like this so far. Building chemical spectroscopy simulations, chromatography, paper chromatography simulations, and now building actual monetary tools for my company here that I work for. And so I've been thinking, I'm like, I wonder like what kind of this thing is like what it's kind of like worth, like in terms of like, does it have actual like monetary value? Like, I don't know. It's kind of funny. I didn't really think about it until now. I'm like, I wonder like if you were to like if to buy it or whatever, what would be what someone would pay for it. Okay, here we go. Let's continue on. So I'm going to take this really quick. I'm through my definition here. Let me refine the phrasing a little bit. The args tells Python take each element out of the iterable arg and pass it as a separate positional argument. Yeah. Right. And then hold on, let me get rid of this. Do function let's break this back out. And then yeah. Let's do function star quarks. Tells Python take each key value pair in the dictionary quargs and pass it as a separate keyword argument. So if you have this function a, b, c, x equals 0, y equals 0, print a, b, c, x, y. We have args 1, 2, 3. And we have quargs x10, y10. We print this, you'll get this. Or Python does the equivalent of this and puts those in there. Key point, star and star star don't pass the containers, okay. Modern replacements for map, filter, and reduce. Functional languages commonly offer the map, filter, and reduce higher order functions, sometimes with different names. The map and filter functions are still built-ins in Python 3, but since the introduction of list comprehensions and generator expressions, they are not as important. A list comp or a gen expression does the job of map and filter combined, but is more readable. Consider example 7.5. Example 7.5 shows that lists of factorials produced with map and filter compared to alternatives coded as list comprehensions. So we're going to list map factorial range 6, whereas we call a list comprehension of factorial n for every n in the range 6. And in 3 we have list map factorial filter lambda n for lambda n mod 2 range 6, whereas this would give us factorial n for n in range 6 if n mod 2. Right. So we'll say I like this example a lot. In Python 3, map and filter return generators, a form of iterator, so their direct substitute is now a generator expression. In Python 2, these functions returned lists, therefore their closest alternative was a list comprehension. The reduce function was demoted from a built-in in Python 2 to the functools module in Python 3. Its most common use case, summation, is better served by the sum built-in available since Python 2.3 was released in 2003. There's big wins in terms of readability and performance. See example 7.6. So 7.6 is sum integers up to 99 perform with reduce and sum. From functools, import reduce. From operator, import add. So we reduce, add, range 100. So what would reduce even do? What does reduce do? Reduce is one of those functional programming tools in Python. It repeatedly applies a function to a sequence of items, reducing it to a single cumulative value. Takes two arguments. Iterable, sequence you want to reduce. Initialize your optional starting value. Sum of numbers. Reduce lambda a and b, or a plus b on numbers. You print result. Step 1, this does 1, 2 equals 3, 3 plus 3, 3 times 3. So reduce lambda a, b, a if a is greater than b, else b. Oh, so this just takes one value, compares it to the next, disregards it, takes that value, compares it to the next, disregards, takes that value, compares it to the next, disregards, until you have one single value reduced down. Oh, okay, so you compare values together here with this add and arrange. Okay, got you. Oh yeah, that's probably a good point. Let me move over there. Thanks, Tarzan. Yo, Grim! How's it going, my guy? Okay, so it applies the function given to each value until a single value in the iterable is left. Reduce takes the first two elements of the iterable, applies the function, then takes that result, combines with the next element, and keeps going until the one value remains. Okay. Interesting. So you have this reduce function, which has function, parameter, and iterable, right, which applies function to the first two elements in the iterable, and applies what, like, is this a form of recursion? It's actually implemented in the loop, so it's not recursion. Okay, so apply something to the first elements of the iterable, and sequence, and repeats with the result and the next element until a final static value is left. Think of like summation. You can do this. Right. Which results in 4950. But you could just so is this function often replaced by newer tech? Newer tech. Modern Python reduces less often used an older style function. Here's why. A lot of common reductions already have built-in sum, max, min, reduce, or these are just faster and easier. Guido van Ross, some Python's creators, even said he regretted putting reduce in Python's built-ins. In Python 3, it was moved to functools. And he starts clarity over pure functional programming tricks. Loops, Python loops are explicit and very readable. Comprehensions, generalizations. Where reduce still shines when you have a total custom cumulative operation that doesn't apply to a built-in. So words, hello world Python, we want to reduce this down to a single string into a sentence. Oh. You can't just say for every word combine with the word and a space afterwards, except for the last word. Do it with the period. I feel like you could easily do this with the loop too. Feel like Guido would like free for a loop here. Is it Guido? You nailed it. It was absolutely preferred something cleaner than reduce here. Your code works fine, but it's kind of smuggled logic. You need to stop and parse that lambda reduce combo. So you could just do join words with a space. Or do a generator, join word for word in words. That's cool. Or just join words on the iterable. Oh, sorry. Yeah, Krim, we dialed in here. We learning. I'm learning some new stuff about Python I didn't know. Like this is kind of like those ins and outs of stuff that I didn't know that really helped me, honestly, get better about like and faster, quickly, as fast as I have been getting better at Python. Like just kind of reading and getting better at these more fundamentals and kind of, yeah. So I'm going to make a note here and say often replaced by built-in functions in newer versions of Python. Some min, max, etc. Other reducing built-ins are all and any. All on an iterable returns true if there are no falsy elements. See, this one I always forget about. This one would be really useful for shorthand tricks, but I always forget that this one exists. So all over an iter, right, returns true if there are no falsy elements in the iter. Then it says all on a blank list returns true. Then we have any. on iter. So returns true if any element of the iter is truthy. Any on an empty list returns false. Same bro, I was learning this concepts called threads, completely new to me. Oh, like you're saying like threads is in like well, thread. Isn't a thread like, it's not like a core, but like you have multiple threads. Like, is that like synonymous for core? Like you can do multiple things at the same time, like asynchronously, assign a different thread to a different task or something to perform, utilize, split up your performance of your computer into different sections and utilize them for different functionalities at the same time. Sargent says, I think so. Cool that you found us here, Sargent. Thanks for joining the stream here. Same with you, my boy Kyrim. Kyrim, it kind of reminds me of that, kind of reminds me of Skyrim, and kind of reminds me of that Pokemon, that ice dragon. Okay, cool. So the all iterable returns true if there are no falsies. So if all of the elements are of true type, of the like all no falsy elements in the interval. So what if you say like all? Can you say key? Does all have a key param that we can use like type stir? Or something? Good instinct to ask, but nope. Smiley face. All and any are super simple built-ins. Their signature is just all iterable. They don't accept any key like sorted or min-max. How all works. It returns true if every element in the iterable is truthy, otherwise falsy. And it stops early, it short circuits as soon as it finds a false value. So you can say, you have a list of words here, which are strings. And you can say all length greater than 1 for word and words. Oh, so you can just create generators then. In a generator expression. And apply the all to the generator expression to determine conditional logic across all of the elements in the iterable. Okay. Okay, so you can apply all or any to comprehensions to apply logic case. Boom! You don't have any key parameter, but you can use comprehensions or generator expressions to apply whatever logic you want to each element. That's really helpful. Note. No. We'll say all and we'll say all iter and any iter do not have a key equals parameter to define logic cases for the truthy falsy truth false evaluation . However, apply a generator comp apply a generator comprehension. This will be bold. To all as the iter and encapsulate the logic within the comprehension. Example. Now we're going to say so we'll do, how do you do it? You do Python? No, you do Python. And then how do you do it? How to write Python in Markdown. Python on the same line. It's a backtick. No. What? Oh, it's 3. Ah. That's right. Let's take copy this. Cool. Good notes. That's cool. I give a full explanation of reduce in vector take number 4 hashing and a faster is equal to on page 411, where an ongoing example provides a meaningful context for the use of this function. The reducing functions are summarized later in the book when iterables are in focus. in, quote, iterable reducing functions, quote unquote, close quote, on page 630. To use a higher order function, sometimes it is convenient to create a small one-off function. That's why anonymous functions exist. We'll cover them next. All right. All right, we'll say left off on page 236. And we'll git add, git commit, start chapter 7. Cool. So we're on page 236. A non-function. Right. We need to get to 250. It's not bad. 14 more pages. Not bad. Not bad. We can probably do that in one more session. I'm liking this chapter though. This one's been a lot more entertaining than some of the previous chapters. It's kind of getting a lot of stuff that you might actually kind of use on a more consistent basis rather than like some Unicode stuff and that kind of stuff. Anywho, I appreciate you guys being here and hanging out with me today. This was a fun little study sesh, chill sesh today. I will go ahead and probably see you guys in the next one. Yo, what's going on, Ray? I appreciate you being here, my guy. Welcome back. You're awesome. Thank you guys so much for being here and hanging out with me, and thanks for pushing me over 3,212 subscribers here. You guys are awesome beasts for sure. I'm having a lot of fun learning Python and writing code at work now. Now that I've been given clearance to be a program and be a developer and get paid to write code some days and try to develop and see if I can make some feasible tools to help out our team and improve things and save money, cut costs, improve quality, functionality, and efficiency, and just I think I can do it, and I think I have done it. I got a good two working scripts for doing this automation tool, two working tools, one for just a single level automation, and then one for a multi-level where it'll do multiple levels of one of a low and a high concentration, and just consider both rather than just one. And so I also wrote in so you can do like mid-process versus at the very beginning, so starting from baseline versus starting from starting from nothing versus starting for some baseline. So it'll factor that off of your ratio, off of your targets. Yeah, it's pretty cool. I'm quite proud of how far we've come with it. I honestly wish I could show you guys, but I can't. I get fired. I'll get fired. I'm not really even sure how much information I can share. Probably not too much. I've been pretty vague so far. I've been just saying, you mix some chemicals together, blah 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 blah. But I can't get into really what it actually is and whatnot. But the math behind it is just pretty. It's not very hard math. It's pretty basic kind of chemistry you learn in college and dimensional analysis and things like that. But on a higher scale for like thinking about dilution factors and things like that. But it's nothing too crazy that not like an experienced biochemist couldn't tackle if they got some practice with it, or just a chemist in general, honestly. But yeah, appreciate you guys being here and hanging out with me. Yeah, we'll see how far it goes, Kyram. I'm kind of building out this. My goal for tomorrow is I need to brainstorm kind of like an interface or some sort of interaction for users or whatever. And then, or just kind of put together kind of a proof of concept with some data to present. to show that this is working and that this is kind of paying off. So because I think I'm getting some pressure, or I think the people like the project managers are feeling some pressure or some heat from people above to get some results on just some projects just across the site in general. And I think that there is some interest in mine because of kind of um, it's kind of cool. It's like not something that we haven't done before. Um, yeah, same. By tomorrow, I need to do some Spring Boot and Threads. Yeah, doing some studying. Yeah, for sure. Yeah, we study almost every single day here. We try to our best. Appreciate you for being here and joining us today, Kyram and Ray, Sarasan, Tim, all y'all. A little bit of a more of a quiet stream today, but it was a fun one with y'all. Anyways, I will talk to you guys in the next one. See you guys.